Hello. Right, what we're going to look at today is we've got 4 exam questions, 4 sort of big mark exam questions, but it's just a lot of information. Now, I'm not actually going to give you the solutions to these today. I'm going to give you hints if they're needed. All right. So remember, if you feel confident, work through the questions yourself. Fantastic, brilliant. I've given you the solutions in the PDF. Okay. So I'm looking at this question here. There's so there's quite a bit of text, quite a bit of information. So this is like a good strategy to begin with, right? I don't like the look of this question. However, there's 5 marks, so I want to get it right. So let's have a quick read through the question. So Liam drives his car. He drives the first 9 miles in 9 minutes. He then drives at an average speed of 70 miles per hour for a certain amount of time. And then he knows this information about his car. So when you're driving faster, 65 miles per hour or less, then he's going to get 50 miles per gallon. So he knows. And if you're driving really fast, then the efficiency of the car kind of actually drops a little bit. All right, you're going to use more petrol to sort of effectively go the same distance. So he needs to know. Says use this information to show that his car uses less than 3 gallons of petrol for the drive. Right, so there's a lot to take in there. So let's just take one bit at a time. So effectively, his journey is in 2 stages. Right, we've got stage 1 and we've got stage 2. So that would be my first kind of point of call. And what's often a good idea is to sort of like think of it a little bit like this. Break it up. Okay, just look at that one bit. Just think about what that tells you. He goes 9 miles in 9 minutes. My question is directly from there is what is that as a speed? Okay. If I look at the second line, it says he drives at an average speed of 70 miles per hour for a certain time. So my question from there is what's the distance covered that might be required? Okay. Distance. Now I don't necessarily need to work out this and this, right? Sometimes you need to look at the question, but it's always worth just saying to you, okay, well what could I work out from that? Actually, I don't think I actually need this bit for the question. All right. Now my first thing is I need to think about the speed. Now the second part's easy because you're going at more than 6. So stage 2, we know we're in there. And then stage 1, we need to work that out. Okay, so I'm going to let you work that out. Right. And oh, sorry, we of course we will need the distance here. Okay. Now, when we're going to work this through, so we can work out the speed there. So that enables us to decide which section we're in. Now, once we've worked out this distance, how's that all going to kind of pull together? Well, it says miles travelled per gallon. So I need to work out how many miles are travelled in each part of the journey. So in the first part of the journey, so stage 1, once you've actually worked out which section it's in, 9 miles. Now you need to think about this as a fraction of it. So let's, for example, if it's this one, that means that you would use 9/50ths of a gallon. Okay, if it was this one, 9/40ths of a gallon. Once you've got this distance, let's say you've travelled 80 miles. Okay, then that would be easy. That would be 2 gallons. It's not 80 miles, all right, but that would be 2. Something else to look out for in this question. Time. Time. This is not a decimal time. Be careful about that. All right. So just something else to think about. Right. Hopefully, there's a few sort of useful hints there to kind of get you cracking on that question. It's not an easy question. All right. So think of it in those different sections. All right. Let's have a look at the other ones. So number 2. Right. Some people look at sort of these kind of questions. Got a circle, a load of lines in it. I need to know my circle theorems. So, and a lot of people like panic on this. Now, The annoying thing about circle theorems is that if you can kind of just identify what circle theorem you need, they're dead easy. And that's often the problem. So again, just looking at the information that we're told. Now, every single piece of information that we're told here is going to be useful. Now, they're all points. These are points on the circle. So that immediately gets me thinking, all right, okay, let's try and remember all those circle theorems. And then it tells me that this and this are straight lines. Now, sometimes it's not a bad idea to do this. If you kind of just go over those two things, just so you can kind of highlight them a little bit. Okay, there we go. Right, sometimes it's worth, you can like even draw it again, or just try and ignore bits of the diagram. Again, I'm looking at it and I'm kind of thinking, like, what would you really want to know? All right, so obviously I want to know this X thing in here. All right, which bit of it, if I was going to tell you something, what would you want to know? All right, now the bit I would want to know is, could you work it out if I told you that? Right, if I told you that, okay, could you work out what X is? All right. So we're kind of working backwards when you're not sure. Wait a minute, I've got my isosceles triangle here. Why is that useful? Look to see which circle theorem you can use, all right, that might be useful here. There you go. I think I've told you enough about that question, all right? All right, now, third one today. Here we go. This sign. So this sign shows when a lift is safe to use. Okay, so total mass of people must be 450 kilograms or less. Right, okay. So Ben and some other people are in the lift. Total mass is, okay, again, it's just like loads of information. All right. So at the moment, it's not safe, is it? Okay, it's not safe. Hey, wait a minute. Look at what's important here. What does that tell you just there? To the nearest 5 kilograms. That means that their total mass is not exactly 525 kilograms. Well, it might be. It's anywhere in between 2 points. It says it's been measured to the nearest 5 kilograms. So what's the lowest point it could be? Now be careful. What's the highest? Be careful with this, because it's the nearest 5. So you need to think really carefully, what are those two numbers, okay? It's like the lower band in the upper band. Alright. Now what happens? Again, it's just like, imagine it a bit of a story, okay? So they're all in the lift's not going to go anywhere because they're too heavy. Right. So Ben gets out of the lift. Alright. Now it's told me some information about Ben. He has a mass of 78 kilograms to the nearest kilogram. So let's now think about, so how heavy there is Ben? What's the lowest weight he could be? And what's the highest weight he could be? Now there's a little bit more going on yet, because is the lift now safe to use? So obviously we've got to try and really show our workings here nice and clearly. So is this lift nice and safe to use? So therefore it's like effectively it's 528 take away 78, isn't it? But if you do that, you're wrong, because you need to take into account one of these numbers take away one of these numbers. We want to think, what's the range of answers that the weight of the lift could be now. Now really what we're interested in is the uppermost of the lift. So what's the maximum answer that we could get in terms of the weight of the people in the lift? Alright, so again, have a go at that if you feel ready. And question 4. Right, what we got here? Let's just show you what. So part A was show that EM is equal to 15 centimeters. So what's always a good idea here? So where is EM? EM's this bit just here. It's given me a load of stuff up here. Good idea here is to write these numbers on there. So that's 16. AE, that's 17 centimeters. So that's that bit. And then it also tells me BC, and that's that bit, okay? Just write those numbers on, alright? Now, what my advice to people is here, so again, it's just recognising a bit of maths that you need. So we want to show the EM, show that that's 15. So let's look at this endy bit here. There you go. You're going to look at that. Alright, just by drawing that bit of it, part of a triangle, isn't it? Alright. What's that? What's that? Show me what that is. Okay? It should work out to be 15. Now the last bit of the question, part B, it says work out the size of angle ECM. ECM. So again, another useful tip about questions. You see here, it says show that. Okay? Part A says show that. You're going to need that number. Alright? That's why they've said it like that. Because if you couldn't do that, then you wouldn't be able to do anything with part B. So wherever it says show that, and you've got a bit that comes after, you can guarantee that you need that little bit of information just there. So my advice to you now would be angle ECM. So this is what I would do, is I would just draw the triangle out where that is. Alright? So I'm just going to do that just underneath. I'm just going to draw this triangle of ECM. What am I going to actually have? I'm going to get a right angled triangle. Whoops, sorry, you're out of shot there, aren't I? Okay, so what am I after? I'm after this angle in here. What do I know? Well, I know EM, look. Just coming back up here. We know that bit. That's 15. So I need to know something else, EC or MC. So let's look at the diagram. If I could get one of those two things, if I can get one more thing about it, can I get EC easily? Not sure about that one. Can I get MC? Wait a minute, I think I can do something with that. Alright? Focus on that. When you've got that, MC, so when we've got that, it's just a bit of trig. Okay? I'll let you do that bit. Alright? Remember, what's a good idea? Notice when I drew this out here, I relabel, I put the vertices on there. I would redraw this bit. I'd label the vertices on there, and then I should hopefully be able to do that quite quickly. Alright? There you go. Right. Hopefully that's been a little bit of use for you just there. Alright? I think the hardest one there is was probably the first question in terms of getting your head round. Okay, you might disagree with me. I think that's probably the trickiest question. All right, there you go. Right, see how you get on.